Steel is everywhere. It's the backbone of our cities, it's the frame of our cars, pretty much the heart of our entire infrastructure. But have you ever really stopped to think about how we get it? I mean, how do we take raw, kind of lumpy iron and turn it into the sleek, super strong stuff that literally builds our world? Well, let's dive into that fiery and honestly fascinating process.
All right, here's how we're going to break it down. We'll start with the biggest problem with raw iron, then we'll look at the chemical recipe for cleaning it up. After that, we'll see the two main ways it's done, a crazy intense oxygen blast, and then another method that uses basically lightning. And finally, we'll see how that perfect steel gets its finishing touches and becomes the icon we know today.
So, first things first, let's get right to the core issue. The raw iron that you get from a blast furnace, they call it pig iron, is on its own surprisingly useless. Seriously, it's brittle, it's weak, and it is just packed with stuff you don't want. It's chemically dirty. Which, of course, brings us to the big question, what really separates that weak, brittle iron from incredibly strong steel? Well, the secret isn't about what you add to it. It's all about what you take away. The key to making something super strong is actually all about purity. And you can see the proof right here in the numbers. That top line, that's your raw pig iron, and look at it. It's loaded with up to 5% carbon and a bunch of other junk. But then look at the bottom line for steel. Whoa, that is a massive drop right across the board. The numbers really don't lie. Making steel is just one giant act of purification. So, how do you actually pull off this purification? Well, the recipe is surprisingly simple. You basically fight fire with fire. By blasting that molten iron with pure oxygen, you can literally just burn the impurities right out of it. And as all those impurities burn, they turn into oxides. Then you add a little bit of lime, and those oxides create this liquid waste product called slag. You can think of it like the scum that forms on top of a soup broth. It just floats right there on the surface, which makes it super easy to skim off and get rid of. The whole chemical dance happens in two main acts. First up, you've got the oxidation phase. That's the big blast of oxygen to burn out most of the bad stuff. And then you've got the second act, reduction. That's the cleanup job, where you get rid of any leftover oxygen and go after any really stubborn sulfur. Okay, so now let's see this whole thing in action with the most common steelmaking method on the planet. This is where all that theory becomes a roaring, fiery reality inside a huge vessel called an oxygen converter. Just try to picture this, a vessel, maybe 10 meters high, filled with liquid iron that's already at 1250 degrees Celsius. Then, a high-pressure lance blasts pure oxygen right into it, kicking off this incredibly violent reaction that cranks the heat up to over 1600 degrees. And the craziest part? The entire transformation from iron to steel takes less than 20 minutes. And you can literally watch the whole dramatic sequence unfold. For the first 4 minutes or so, sparks are just flying as the silicon burns off. Then, for the next 10 minutes, you get these intense flames erupting as the carbon is incinerated. And finally, right around the 15-minute mark, you'll see this reddish-brown smoke. That is the crucial signal to the operators that the iron itself is starting to burn. It means the job is almost done. But that oxygen converter, it's not the only game in town. There's another major player. And this one is an absolute champion of recycling, the electric arc furnace. Instead of starting with liquid iron, this method starts with a bunch of scrap metal and melts it down with what is, for all intents and purposes, a controlled lightning strike. And these two methods really serve very different purposes. The oxygen converter, it uses liquid iron and its own chemical reactions to generate heat, which makes it perfect for churning out massive volumes of steel. The electric arc furnace, on the other hand, uses scrap metal and electric heat. That makes it a recycling powerhouse and the absolute go-to for making high-quality, specialty steels where precision is everything. And the key to all that precision is temperature control. The electric arc can reach an incredible 1800 degrees Celsius, and that heat is super easy to adjust. This lets steelmakers melt even the toughest materials and gives them the fine-tuned control they need to craft all sorts of advanced alloys. All right, so whether the steel came out of a converter or an electric furnace, we're not quite done yet. We've got a bath of pure liquid steel, but to get the exact properties we want, it needs a few final, very precise touches. This is where steelmaking goes from being a brute force operation to something more like a fine art. As one of our sources puts it perfectly, these final additions have two critical goals: to deoxidize the bath and to recarburize it. So, in plain English, That means first, they get rid of any leftover oxygen, and then they add back a very, very precise amount of carbon to get the exact strength and hardness they're looking for. So, what are these final ingredients? Well, deoxidizers like ferrosilicon and ferromanganese get tossed in to grab onto any spare oxygen atoms. In the electric arc furnace, they can even create this special reducing slag that is incredibly good at pulling out the very last, most stubborn traces of sulfur. And the results are what really matter here. The goal is to get impurities below 0.05%, which is already tiny. But modern processes just absolutely crush that goal. We're talking sulfur down to just 0.008% and oxygen down to 0.003. That is just an astonishing, almost unbelievable level of purity and control. So, let's bring it all home. We've gone on this journey from a fundamental problem, weak, impure iron, all the way through this fiery crucible of purification. And you have to realize, this transformation isn't just some industrial process. It is the very foundation of the modern world we all live in.
If there's one thing to take away from all this, it's this. Steel isn't just iron that's been made stronger. No, it's what's left behind after a violent yet meticulously controlled purification process burns away all the weakness, leaving behind a material that has been perfectly engineered for strength.
From skyscrapers to surgical scalpels, this fiery birth has given us the one material that has defined the last century and a half of human progress. So the only real question left is, what are we going to forge with it next?